Hi everyone, we'll go through the solutions for the VCAA quiz number 4. So most of these can be done without too much calculation actually. So if you know your maths well, you can probably look at the question and think about the graph or what the answers are to actually get the answer, or not what the answers are, what the responses are, or the distractors in the multiple choice section. Anyway, let's get started. So consider the tangent to the graph of y equals x squared at the point 2, 4. Which of the following points lies on this tangent? So you need the tangent equation first. So you can do that by hand by finding the gradient, but it's just easy to do on the calculator. So let me just get the calculator up. I did this before, so I've already got the working out there, but I'll do it again just to show you where to go. So interactive, now calculation, and then go down to line. And we want the tangent line. You can see you can also get the normal there. All right, it does say expression, so don't write y equals. So remember, an expression is without an equal sign. So we just want the x squared. The variable is x, and we want it at the point x equals 2. You don't have to put the 0.24 in because the calculator will do that for you. All right, it's going to substitute 2 in. All right, and there's your tangent equation. So we've got the equation y equals, now it went away, 4x minus 4. All right, so that's our tangent equation. We can also, let me just see if I can make that a bit smaller. Just see my calculator. We can also just do the rest of the question on the calculator as well. So if I just drag down that and just substitute in values for x. So the first one, x is equal to 1. So this line means given that x equals 1, and I get 0. So it's not that one. Let's try another one. X equals 3, y equals 8. So the correct answer for number 1 is B. Obviously, you can do all this without the calculator. It just depends, I guess, how quick you are with your calculator as to whether you're actually saving time. All right, question 2. If f dash x, so your derivative function, equals 3x squared minus 4, which of the following graphs could represent the function of y equals f of x? This question I love because you should know that the original graph, if this is a parabola, this should be a cubic. And if we look at all our responses, only B and D are cubics. So that means you've got, if you had to guess it, a 50% chance of guessing it correctly. All right, but we don't really want to have to guess. So let's think about this derivative function. So it's 3x squared minus 4. And I'm going to look at A because it looks pretty much, the graph in A looks like 3x squared minus 4. It's a parabola that's been shifted down 4. So that means it's crossing the axis, the x-axis twice. That means it's got 2 stationary points. I'm not talking about the graph of A, I'm talking about A being the derivative. All right, just to show you what it looks like. So when your derivative crosses the x-axis, that means your gradient is 0. So that means your graph of f of x, has 2 stationary points. And I can see the difference between B and D is B has 2 stationary points. It's got one here and one here. And D has just 1 stationary point, which is here. So your correct answer for that one is B. All right, question 3, which we can just not see on the page. Let's just make it a little bit bigger. All right, so for the function with the rule, I'll make it a little bit bigger on this side too. See the whole question yet? Oh, did I not? There we go. All right, so for the function with the rule f of x equals x cubed minus 4x, the average rate of change of f of x with respect to x on the interval 1, 3 is. So whenever you see average rate of change, you're just, sorry, oh, where'd my pen go? All right, let's come back. So whenever you see average rate of change, Just remember, it's your gradient. It's your rise over run. It's the difference between your 2 points. So we know we've got, this is an interval. It's not a coordinate. So this means x equals 1 and x equals 3. All right, so we just need to know what the corresponding y coordinate is. So we've got to substitute in 1 into this function. So 1 cubed is 1 minus 4 gives me -3. And then when I substitute 3 in, I get 27 minus 12, which is 15. All right, so we're just doing rise over run. We've got our 2 points now, 1, -3, and the other point is 3, 15. And just the difference in your y values over the difference in your x values. So 15 minus -3 over 3 minus 1 gives you 18 over 2, which is 9. So the correct answer for that one is E. All right, question 4. The equation x cubed minus 9x squared plus 15x plus w equals 0 has only one solution for x when. All right, so this is a little bit trickier. You do need to draw the cubic as the easiest way to do it. Actually, probably not. It's the way I did it. Okay, so if we just draw this part. So I did this earlier, all right, on this software, but you can do it on your calculator as well. And I've just also identified what the local maximum and the local minimum is. So basically, here's my function, x cubed minus 9x squared plus 15x, and I can shift the graph up or down. So I can shift it up 10 if I do plus 10, I can shift it down 15 if I, minus 15 if I want to. Okay, that's what's happening. So let's have a look at the graph. All right, so we only want it to cross the x-axis once. So I can see if I bring the graph down, I don't think I can draw on this, no. So if I bring the graph down, it's only going to cross once on the this side. Okay, so let's do that. So I can see it's 7. So once I bring it down 7, if I go minus 7, it should now be, that turning point should now be on the x-axis. All right, so do you see it is there now? So your local maximum has moved. So it's still hitting the x-axis there. So that means x has to be less than 7. Sorry, x less than -7. Sorry, it's not x, it's w. It's just probably needed to erase it. There we go. All right, so we're not using x, we're using w. So w, all right, the constant that we're either adding or subtracting has to be less than -7. All right, so I just showed that there. So I put -7, but if I put -8, it's now going to be below the x-axis, okay, and it's only crossing here once. All right, so your local maximum has moved. All right, I wonder if I can just get rid of that. It's a bit in the way. All right, let's go back to our original graph. All right, so there's my local maximum. So what do you think I need to do now to make sure it only crosses once? I need to move this graph up 25. All right, so if I add 25, it's going to hit the x-axis now. All right, so see, it's now hit the x-axis. So anything greater than 25, so if I do 26, it's only going to hit once over here. So that means w has to be less than -7 or w has to be greater than 25. So the correct answer for that one is D. All right, last question. So this one's oh no, I thought it was a bit bigger than that. It wasn't going to fit on the page. There we go. All right, I actually really like this question because it is a bit of a tricky one and it just means you have to think. All right, you don't rush and just think about the first answer. All right, so we've got to find the rule for this function or a possible rule. So we've got x-intercept here at B, 1 at C, and 1 at D. What I've got at C is a repeated factor. All right, so this is a repeated factor. And what that just means is that turning point, instead of just being x minus c, it's x minus c squared. This one here, now even though b is, I guess, in the negative part of our x-axis, it does say b is positive. So I've got to write that as a factor of x minus b, and d is x minus d. All right, so just the factors for our, it looks like a quartic. All right, so let's just write them down, put them all together. X minus c squared, and then x minus d. All right, so looking at our responses, if we did a process of elimination, we want the x minus b. So it can't be a, can't be b. All right, so we're looking at c, d, and e. Let's see if there's any other differences. E, you've got an x plus c, so it can't be that one. So we're choosing between c and d. And this is why it's important to take your time. So you can see the main difference between them is one is a -2, our value of a is -2 for c, and then for d it's +2. This quartic, hopefully you know, is a negative quartic. So it's been reflected along the x-axis, indicated by that negative. The 2 doesn't matter. It's that negative that tells us that it's the correct graph. So your answer for question 5 is C.